In this class, now I am going to explain you inverse trigonometric functions. As we know that basic trigonometric functions are many to one functions in its domain. So if the functions are many to one functions, as we know, whose inverse will not be existed because many to one functions are not bijective functions. Okay, but to get inverse functions for the trigonometric ratios, so we have to prefer whose principal domains. Okay, as you know, while we were discussing that graphs of trigonometric functions, there I explained you about those principal domains. Okay, so the principal domains are the domains in which the functions are bijective, hence whose inverse will be existed. Okay, so now let us see the basic trigonometric functions and whose original domains and the principal domains and the ranges. Ranges are nothing but like you can call them as principal values also here. Now let us observe. See, the function and whose domain principal domain, here PD stands for principal domain, and range. So you know, see, the first function is sin x, whose domain is set of real numbers. As we know, sin x is defined on the entire real number set. Now whose principal domain is minus 90 to plus 90. Okay, yeah, radians, pi radians. Okay, and whose range is minus 1 to 1. Similarly, cos x, whose domain is set of real numbers. Even this function is also defined on the entire real number set, whose principal domain is 0 to pi, and the range is minus 1 to 1. And let us go to tan x. So you know, the domain of tan x is r minus odd multiples of 90, pi radians by 2, where n belongs to z. Tan function will not be defined at odd multiples of 90, like 91s, 93s, 95s, 90 minus 1s, 90 minus 3s. Okay, so that those angles I have subtracted from set of real numbers. Okay, right. Now whose principal domain is open interval of minus 90 to 90, and the range is set of real numbers. Now let us go to the cot function, cot x. So cot function will not be defined at even multiples of 90, like 92s, 94s, 96s, 90 minus 2s, 90 minus 4s, like that. N pi, where n belongs to z. So here whose principal domain is open interval of 0 to pi, whereas the range is set of real numbers. Similarly, cosec function, cosec x. So domain is r minus n pi, where n belongs to z, and the principal domain is closed interval of minus 90 to 90, and 0 must be subtracted because cosec 0 is not defined, so that I subtracted 0 from this interval, and the range is minus infinity to minus 1, closed union 1 to infinity. Okay, next sec n x. So whose domain is r minus odd multiple of 90, where n belongs to any integer. Here z means set of integers. So principal domain of sec n x is, so close interval of 0 to pi, but minus, see here 90 should be subtracted because secant 90 is not defined. So from this interval you have to subtract 90 degrees. So range for the secant x is minus infinity to minus 1, closed union 1 to infinity. So these are functions and whose domains and whose principal domains and ranges. Okay, so here what is meant by principal domain? Principal domain is a domain in which these functions are bijective. Okay, now hence, so if a function is bijective, hence whose inverse is possible, means that function is invertible. Okay, in its domain, all these functions are in its principal domain. Okay, either that function is strictly increases or strictly decreases. So observe the graphs of these functions in its domain, principal domain. So clearly what we people can observe, either those functions may be strictly increases or strictly decreases. As we know, strictly increases and strictly decreasing functions are always bijective, hence whose inverse is possible. Okay, so these functions are defining from this domain to this range. Okay, in this inverse trigonometric function, so what you people have to consider, see this principal domains and the ranges of these basic trigonometric functions. Sin x principal domain is this. Okay, and whose range are principal values minus 1 to 1, and cos x principal domain is 0 to pi, and whereas range is minus 1 to 1, close interval of minus 1 to 1. You know the meaning of close intervals and open intervals. So here minus 90 to 90, tan x principal domain, range is capital R, cot x principal domain is 0 to pi, range is capital R. Now cosec x principal domain is minus 90 to 90, but 0 must be subtracted, and see the range. And secant x principal domain is 0 to pi, and 90 must be subtracted from this interval, because you know at secant 90 not defined, and range is minus infinity to minus 1 union 1 to infinity. Okay, to define inverse of this trigonometric function, you people have to remember this principal domains and whose respective ranges. Okay, now let us go to inverse of these functions. Right, as you know, suppose if a function is defining from set A to set B, okay, f is a mapping from set A to set B. If this function is bijective, then whose inverse will define from B set to A set. Okay, here if a function is defining from set A to set B, and also if it is bijective, then that function is invertible and which will map from set B to set A. So for this function, domain is A, range will be B. Okay, because I am saying that it is a bijective function. In bijective function, as you know, codomain equal to range. Okay, and here whose inverse will map from B to A. Okay, here observe that B is the domain of inverse function and A will be the range. But for the basic function, B is the range, but for whose inverse, B is the domain. For the basic function, A is the domain, but for whose inverse function, A is the range. Okay, right. Now let us see the function and whose domain and a range. Now the first one is sine inverse of x. Tell me whose domain? Close interval of minus 90 to plus 90 and the range is minus 1 to 1. Just that for the basic functions, principal domain and range we have seen, no? So when you come to whose inverses, this domain and range just will be interchanged. Okay, I think you are observing this. Now let us go to cos inverse of x, whose principal domain is 0 to pi, and whereas range is minus, here for sine inverse of x, domain will be minus 1 to 1. Okay, na? Because here we are writing inverse functions of basic trigonometric function. So obviously this domain and ranges will be interchanged. So minus 1 and 1 was the range for the basic sine function. But whereas for whose inverse, it will be interchanged. Means whose domain will be minus 1 to 1. And okay, range minus 90 to 90. Okay, right. For cos inverse of x, minus 1 to 1. And the range 0 to pi. And for tan inverse of x, okay, so domain is set of real numbers. And whereas range is open interval of minus 90 to 90. Okay, right. Let us go to the cot inverse of x. So domain is set of real numbers. And the range open interval of 0 to 90, minus should be subtracted. Okay, now let us go to cosec inverse of x. Okay, so domain is minus infinity to minus 1 union 1 to infinity. And whereas range, so this one only, close interval of minus 90 to 90, but 0 must be subtracted. 0 must be subtracted. Okay, right. Next. Okay. Right. Here, okay, here 0 to pi will come, not 0 to 90. Okay. So completely 0 to pi you will get. Okay, because here tan 90 is not defined, but when you take whose inverse, so cot 90 is 0, no? So that cot function will be defined at 90 degrees. So that here 0 to pi. So the domain of, principal domain of cot function is 0 to pi. And range is set of real numbers, but when you go to whose inverse, so domain is capital R. And range will be 0 to pi. Now let us go to the secant inverse of x. So whose domain is minus infinity to minus 1 union 1 to infinity. And whereas range, so close interval of 0 to pi and 90 should be subtracted. Okay, so these are the domains and these are the ranges of this inverse trigonometric functions. Okay, now let us go to learn the graphs of this inverse trigonometric functions. Now First, let us see the sine function. Okay, right. See the sine function. Let us consider f of x equal to sine x. Okay. Now let it be y. Similarly, here f of x equal to sine inverse of x. Sine inverse of x, and let it be y. Okay, students, you know, right? See, what is the principal domain of this side? Minus 90 to 90, and whereas range is minus 1 to 1. When you go to whose inverse function, minus 1 to 1 is the principal domain, and the range will be minus 90 to 90. Okay. Now on the same graph, now I would like to draw both graphs. Okay, this is basic trigonometric function and it is whose inverse. Both I want to draw on the same graph. See how I am drawing. This is y axis and this is x axis. Okay, you know, this is origin. Now right here take 90 degrees and here it is minus 90, and here you take minus 90, you can take over here plus 90 because positive y axis, and here you take minus 90. Okay, right. See here pi means how much? Pi radians, approximate value 3.14. 3.14 value is 1.7 something, no? So you may get 1 over here, and here you may get minus 1 here. On the y axis also you may get 1 here, and you may get here minus 1. Okay, now first let us draw the graph of sin x in its domain, minus 90 to plus 90. If you put a domain value minus 90 for x, sin of minus 90 is minus 1. So on the x axis, you know, while drawing the graph, we take the domain on x axis whose respective range on y axis. Now domain is minus 90. If you write minus 90 here, whose respective range will be minus 1. Somewhere here you will get. When you put here 0, sin 0, 0. And when you write 90, sin 90, 1. Sin 90, x value is 90. Y value is here 1. Okay. So you will get the sine function graph like this. Between minus 90 to 90, you get the sin x graph like this. Okay. Now let us go to the sine inverse of x. So here minus 1. Now observe the graph of sin x. It is strictly increases now in its principal domain. Hence it is bijective. Hence whose inverse will be existed. If the graph of sin x is strictly increases in its domain, then whose inverse function also will be strictly increases. Okay. Now let us see whose graph. Put a domain value x equal to minus 1. Sin inverse of minus 1. Okay. Is equal to how much? Minus 90 you will get. Okay. See here. Sin inverse of what I am writing? Minus 1. If you write here minus 1. So here. Okay. What you have to write? When do you get minus 1 here? Sin of minus 90. Sin inverse of sin theta is equal to theta. Minus pi by 2 is the principal value for this principal domain minus 1. When you put x equal to minus 1, your respective range will be minus 90. Okay na? So here minus 1 is the principal domain value, and the principal range value minus 90 means here you will get. Similarly, when you put 0, 0 you will get. Middle 0 will be there now. If you write here 0, sin inverse of 0 is 0. Okay? And if you write 1, when do you get 1? Sin 90. When you write domain value 1, respect to range will be here 1, 90. Domain, we have to take from the x-axis. We kept here sin inverse of 1. Now this one you have to express in terms of sin 90. Sin inverse of sin theta is equal to theta, means pi by 2 you will get. Pi by 2. Okay? Now if you draw the graph, you may get like this. Okay? What is this? Graph of sin inverse of x. What is this? Graph of sin x. Okay? So basic function and whose inverse function, both I have drawn on the same graph in its principal domain. Okay? Right. Now observe. How are these two graphs? Both are mirror images with respect to y equal to x line. Okay. So here minus 90 here. Here plus 90 here. Somewhere here you may get. This is graph of sin inverse of x. Okay. Now connect minus 90 to 90, plus 90 to plus 90. What is this? Y equal to x line. Angular bisector for the first quadrant and third quadrant, which makes 90 degrees with x-axis. You know, the line which passes through origin will be in this form, y equal to mx. Slope form of a line or gradient form of a line. So this line will make 45 degrees angle with x-axis. So that you know slope tan 45 1. So that m equal to 1 if you write y equal to x. Okay. So this sin x graph and whose inverse graph, both are mirror images with respect to y equal to x. Mirror images means y equal to x line you have to treat as a mirror. Then graph of sin x, the image of sin x will be sin inverse of x. The image of sin inverse of x will be sin x, vice versa with respect to y equal to x. Okay? And observe both graphs. Both are not periodic functions in its principal domains. Both are not periodic. You know what kind of functions are known as periodic functions? Periodic functions are nothing but in its domain, same shape of graph we have to get. Means that graph should be repeated in more number of, more than once that graph has to be repeated. But here that same shape of graph is not repeating in its domain. Hence this sin x and sin inverse of x are not periodic functions in these intervals. Okay? I hope you have understood this. Now let us go to one more function which is based on combination of these two. Okay? Now observe that. Right? Now see this function f of x is equal to sin inverse of sin x. Sin inverse of sin x. Okay, let us consider this function is equal to y. Now tell me, see, what is the domain of this function? Set of real numbers. Because you know the domain of sine function is set of real numbers. If you assign x equal to any real number, then sine function will be defined and it will be given range -1 to 1. Okay. Right. If it is -1 to 1, okay, that will be the domain of sine inverse of x. And finally, what kind of range do you get? -90 to 90. Okay, students? So, no confusion here. Sine inverse of sine x. X can take any real number. And write here and simplify. This range will be -1 to 1. And if you take any value for -1 to 1 in this place and find whose respect to range with respect to sine inverse, finally you will get this will be the range. Okay, -90 to 90. Okay, right. So, see, observe me. What kind of solutions do you get? Observe for this function. And when you take sine inverse of x left side, it is going to be sine y. Sine y, which is equal to sine x. Now write the general solution for this. You know, you come across that trigonometric equations. There you got general solution for this is y equal to n pi plus -1 whole power n here x, where y belongs to -90 to 90. Okay, see, this total thing we have considered as y, then your y should be -90 to 90. Okay, so suppose if n is equal to 0, then what do you get for y? Tell me, what do you get for y? So if you put n 0, okay, y equal to x you will get. Okay, now write here. If n is equal to 0 and respective y value is x. Suppose if n is equal to 1, then respective y value put 1, n equal to. So go for simplification. You will get y equal to pi minus x. If n is equal to 1, y equal to pi minus x will come. And next, if n is equal to 2, you know, in the trigonometric equations, n belongs to an integer. I am writing some integers. If n equal to 2, if you write here, so what do you get for y? Y equal to 2 pi. So -1 whole square becomes positive. 2 pi plus x you will get. So if n is equal to 2, you will get y equal to 2 pi plus x. And so on. If you keep on substituting n equal to integers, you will get different values for y. Okay. Now let us observe whose graph. Right. Now see here, I am drawing the graph of y equal to sine inverse of sine x graph. Right. See. This is x-axis and it is y-axis. Now take 0 here and here it is 90. And here it is pi and 3 pi by 2, 2 pi, 2 pi. Here it is 5 pi by 2, here it is 3 pi, here it is 7 pi by 2, and so on. This is x-axis. Okay, left side minus pi by 2, and here it is pi, and here it is minus 3 pi by 2, and here it is minus 2 pi, and so on. On the y-axis, here it is minus pi by 2, here it is plus pi by 2. Okay, now observe, okay, graph of this function. Okay, so as I said to you, this inside sine range from where to where? Minus 1 to 1. If you write minus 1, you will get here. Plus 1, sine inverse of 1, just now we have seen 90 you will get. Okay, actually sine inverse of sine x. Don't say it as y equal to x, it will vary. Sine inverse of sine x equal to actually x you will get, but that x must be belonging to minus 90 to 90. I will explain you some applications also after this graph. Just observe this graph how I am drawing. See, students, see, actually here x belongs to any real value you can take from x-axis and write for x. So this interval will be minus 1 to 1. If you write any value from minus 1 to 1 here, in the simplification this sine inverse will be given from minus 90 to plus 90, because range you have to take on y-axis, domain on x-axis. So for x you can take any value from the x-axis and write here, and here sign is there, so that minus 1 to 1 will come. Okay, minus 1 to 1. So if you write minus 1 to 1 here, okay, so what do you get? Minus 1 to 1 here. So your respective range will be minus 90 to 90. Am I right? So I am giving x equal to 90. Okay, if you write x equal to 90, sine 90, sine of minus 90, minus 1, and sine inverse of minus 1, minus 90. Are you getting me? Domain value I took minus 90, and I am writing here sine of minus 90 minus 1. This complete result was given minus 1. Sine inverse of minus 1 is minus 90. You have to take on y-axis. So domain is minus 90, final range is minus 90. Similarly, if you write 0, if you put 0 here, sine 0, 0. Sine inverse of 0 also 0 will come. And if you put 90 degrees for x, sine 91, sine inverse of 1, 90. So domain is 90, range will be 90. So you will get the graph like this, y equal to x. Okay? Right. So suppose if your domain value is 90 to 270. 90 to 270. So here, if you write x value 90, range will be 90, okay. But if you write x value pi, sin pi is 0. Sin pi is 0. So when you put x equal to pi m here, sin pi 0. So inside you got 0. So sin inverse of 0 is 0 only. So you get the graph like this. It intersected pi, and it will go like this. Between 90 to 270 you get like this. When you put x equal to 3 pi by 2 here, sin of 270. Okay, so sin of 270 is minus 1. So here this result is minus 1. Sin inverse of minus 1 is minus 90. No confusion. See here, when you put to domain value 270 here, sin 270 is minus 1. Now sin inverse of minus 1 is, sin inverse of minus 1 is how much? So this you have to express as in the principal domain minus 90. So final result is minus pi by 2. Like this you will get. And next 270 to 270 to 450. So you get the graph like this. Yeah, 90. When you put 450, respective range will be 90. So like this you will get. And 450 to 750. Through the 3 pi you will get here line. When you move left side also, minus 270 respect to range is plus 90. So like this you will get, and like this it will go. Okay students, now this is the graph of sine inverse of sine x. So is this periodic function? Yes, absolutely it is a periodic function, because so from minus 90 to plus 90 strictly increases, and plus 90 to 270 strictly decreases. One increases, one decreases. Again minus 90 to 90 pi, 90 to 270. So minus 92 to 270, total length is 360 degrees. 2 pi radius. After 2 pi radius, in this 2 pi radius length increases, decreases. Again increases, decreases. Again increases, decreases. Coming now, after how much length of interval same shape of graph is repeating? 2 pi radians. Hence, it is a periodic function with period 2 pi radians. Okay? So, it is a periodic function, and okay, that graph will repeat like this. Okay? So, from here to here, this is making how much angle with the x-axis? 45 degrees. Hence, whose slope is 1. Hence, whose equation is y equal to x, because passing through the origin. But this line is passing through this point, no? So let it be pi comma 0. And this line is making how much angle with the x-axis? Okay, 135 degrees. Okay, so 135 degrees. You know, tan 135 degrees minus 1. Okay, so the slope of this line is minus 1. So here this line slope minus 1 and passing through pi comma 0. Then apply, okay, point slope form of a line equation. Y minus y1 equal to m into x minus x1. Now y minus y1. Here y1 is 0 and m value minus 1. X minus x1 pi. Now simplify this. On simplifying this, you will get pi minus x. Okay? So this line equation is how much, Amma? Y equal to pi minus x. Okay. Pi minus x. So shall I give you one application based on this? Right. Now, see students. Sine inverse of 2 pi 5 pi radius by 4. So this kind of questions we may get. Then what is the result? Sine inverse of sine 225 degrees. What is the simplification? In the simplification, sine inverse of sine x equal to x, you may write, but that is not correct. A sine inverse of sine x, in the place of sine x, what you are getting? Sine inverse of sine x is equal to x, you said here. Sine inverse of sine x. Don't say it as x. It is x when domain value is minus 90 to 90. But when x value is 90 to 270, don't write direct as pi radius by 4. This is wrong. Because, you know, range for the sine inverse of sine x is, as I said to you, minus 90 to 90, no? We have to get the result, minus 90 to 90. But you got 225 degrees. This is wrong. So, to get in the interval minus 90 to 90, so here, when x value is 90 to 270, y equal to how much you have to take? Pi minus x. Okay, na? So, now write here, pi minus x. Pi means pi minus x. 5 pi radius by 4. Now, in this simplification, you will get minus 45. Minus 45 belongs to minus 90 to 90, no? Okay? You can answer like this to this question. Sine inverse of sine pi radius by 4. Okay, na students? So, otherwise, you can do in one more way also. First, simplify this. Sine 225 means, you know, sine 180 degrees plus 45 degrees. Sine 180 plus 45 minus sine 45. Now minus 1 by root 2 you will get. Now minus 1 by root 2. So hereafter, okay, in minus 90 to 90 interval, at which angle? So this will be given minus 1 by root 2. Here, in this simplification, minus 1 by root 2 you got. This you have to express in terms of sine of an angle which belongs to minus 90 to 90. In minus 90 to 90, so at which angle it is going to be given minus 1 by root 2 means sine minus 45 degrees. Sine inverse of sine minus 45 equal to minus 45. Okay. So you can use this y equal to pi minus x formula. Otherwise directly simplify this, and after getting this result it has to be expressed in terms of sine and go for simplification. Okay. Right. So next, suppose if this x belongs to, okay, 270 to 450 degrees, 3 pi radius to 5 pi radius by 5 pi radius by 2 means 270 to 450. Okay, what is the value for y means? See here, see the line how it is passing through the 2 pi comma 0 now, and here this line is making how much angle with the x-axis? 45 degrees. So it is coming like this means 135. Slope will be minus 1. Here it is making an angle 45 degrees. Hence whose slope is 1. So here slope is 1. Okay. And passing through the point 2 pi comma 0. Hence apply point slope form. Y minus y1 equal to m into x minus x1. Now y minus y1. y1 value is 0. M value 1. Now x minus x1. x1 means 2 pi. Okay. So your result will be y equal to, tell me students, x minus 2 pi or minus 2 pi plus x. However you can write. Minus 2 pi plus x you can write. X minus 2 pi when x belongs to 270 to 450 degrees. Similarly this side also. It is passing through minus pi comma 0 no? And here it is having slope minus 1. Use this slope, use this point. Apply point slope form. Y minus y1. So y1 is here 0. Now m value minus 1. Now x minus x1. x1 is, okay, minus pi. But in the formula minus is there, which becomes positive. So now y equal to, okay, minus x minus pi you will get. This line equation. Y equal to minus x minus pi. Okay. Right. You have to move like that. Okay na students. I hope you have understood how you have to answer to this question. So what is this? Graph of sine inverse of sine x. And also I taught to you application based on the sine inverse of sine x. Okay. So see. Right. Now let us go to the cos inverse of cos x. Okay na students. So sometimes you see in the same question they will give you like this. Sine inverse of sine 3. Sine inverse of sine 3. 3 given means what you have to understand about this 3. 3 is there in the radian measure. Okay na students. Sine inverse of sine 3 is equal to, don't write directly as 3. Okay, 3 means at what you have to understand about this 3. It is there in radian measure. You know, if it is given in radian measure, you better to convert into the degrees. Okay, so you know, so 3 radians you can write as 3 into 1 radian. So you know 1 radian is equal to approximately 57 degrees 18 minutes. Now multiply with 3 on both sides. 3 radians equal to, when you multiply with 3, how much do you get? Around 170 change. Because, okay, 63 is a 180 no? So this result will be between 172 to 180. 172 to 180 means what you have to take? See here, 170 to 180 means here this one you have to take. Okay, here this result 3 radians belongs to this interval. So on this simplification, 3 into 57 degrees, 18 minutes, no. How much will it be? Around 170. 170 means smaller than 180, no? So here this line you have to prefer. Pi minus x. Okay. So what is this result? Sine inverse of sine 3 is equal to pi minus 3 outright. Pi minus 3. Okay, na students? 3 is there in radian measure. Okay. So based on this, we will get applications in the competitive exam. Right. Now let us go to the cos inverse of x. Cos inverse of cos x graph. See, now y is equal to cos inverse of cos x. Okay, students, and before going to draw the cos inverse of cos x, let us see the cos x and cos inverse of x graph. Y equal to cos x and y equal to cos inverse of x. Okay, right, you know whose principal domain is 0 to pi, and whereas range is -1 to 1, and here principal domain is so -1 to 1, and whereas range is closed interval of 0 to pi, but okay, 0 to pi only. Okay, students. All right. Now let us see whose graphs. See, both graphs I want to draw in the same graph paper. X dash, y dash. Students, observe carefully. What is the domain of principal domain of cos x? 0 to pi. Range is -1 to 1. Whereas when you go to whose inverse, this will be the domain and this will be the range. Okay. Now, see, here you can take 90, and here you can take pi, and here also you can take minus pi by 2, minus pi by 2, and here you can take minus pi, and here write pi radians, and here 90, and here minus 90, here you can take, and here it is 1, and here it is -1, here it is okay, minus 90. Okay, leave it. Now here you may get -1, here you may get +1. Now first let us see this graph. So domain is 0 to pi, 0 to pi, 0 to pi. Now draw the graph of cos x in the 0 to pi. When you put x equal to 0, okay, respect to range, cos 0 is 1, means here you will get. Okay, domain we are writing 0. Domain 0, where do you get on the x-axis 0? Here at origin. X value is 0. If you write x value 0, cos 0, y value 1. Here you will get 0, 1. This is origin. And when you write x equal to pi, cos pi value, cos 180 is cos 180 -1. So where you have -1, pi -1. Here pi radius, and -1 is here. When you put x value 90 here, 90 belongs to this interval. When you write x equal to 90, cos 90 is 0. So here you will get. So between this 0 to pi interval, your cos x graph you will get like this. This is the graph of cos x in the interval 0 to pi. Okay, I hope you have understood how I have drawn. Now let us go to the cos inverse of x. Here observe this, strictly decreasing, no? Domain values are increasing, range is decreasing. Hence, cos x graph is decreasing function in its domain, principal domain. And go to this cos inverse of x. When you put x value -1, respective range will be pi. Where is -1? Here. Range will be here. Pi radians on y-axis. And when you put x value 1, cos 1, when do you get 1? In this interval, 0 degrees. Okay. So 0 degrees means when you write x equal to 1, respective range is 0. And at 90 degrees means, okay students, here in between there is 0. When you write 0 here, 90 you will get. So you get the graph like this. This is the graph of cos inverse of x. Are you understanding how I am drawing this? See, domain values -1 to 1. Now I kept to -1. Cos inverse of -1 is equal to pi. Domain is -1, respect to range is pi. And I took 0. 0 belongs to this interval. I kept here 0. Respect to range 90. Cos 90 0. 0 means you can express it as cos 90. And here 1 means respect to range is 0. You get the graph like this. So this is the graph of cos inverse of x. And this is the graph of cos x. And again, both are mirror images. Okay, for y equal to x line in the interval 0 to pi. 0 to pi here. Pi. Here you will get no somewhere here. Pi to pi. So this curve and this curve, both are decreasing. Both are mirror images with respect to this line y equal to x. Treat this as mirror. And see the image of this cos function in this mirror, you will get this image. And see the image of this cos inverse in this mirror, you will get this. Okay, I hope you have understood both graphs, cos x and cos inverse of x on the same graph paper. Okay, now let us go to combination of these two. See, both are not periodic functions in the interval 0 to pi. Right. Now let us go to cos inverse of cos x. Right. Now let us take y equal to cos inverse of cos x. So cos inverse of cos x is equal to, directly you want to say x. Tell me students, it is x, but when x belongs to 0 to pi. If x is actually here, what is there? Cos x is there. You know, cos x domain is set of real numbers. That real number set is 0 to pi. Okay, result will be x. But x every time, x need not be belongs to this, no? Because cos function will be defined for entire real number set. Okay, so you know, so if you think about this function, it is defined for all the set of real numbers, but whereas range will be close interval of 0 to pi only. This range y must be 0 to pi. Y belongs to 0 to pi only. But this x will take any real number. Okay. Now if you assign x will value any real number, on simplification this will be given -1 to 1. -1 to 1. But before that cos inverse of is there. Finally you have to get 0 to pi. Okay. Now observe this graph. Observe carefully. Actually, when you take cos inverse of x left, cos inverse of y left side, cos y is equal to cos x you will get. If you write the general solution for this, y equal to 2n pi plus or minus x you will get, where y belongs to compulsory 0 to pi. Okay na students, right? So here also, suppose if you assign n equal to 0, then your respect to y value will be, y value is equal to, when you write n equal to 0 respect to y value plus or minus x, it may be y equal to plus x or minus x. When you write n equal to 1, your respect to y value, tell me students, when you write n equal to 1, 2 pi plus or minus x. Similarly, if you write n equal to 2, your respect to y value, 2 to the 4 pi plus or minus x, and so on, because where n belongs to any integer. Right, now let us observe whose graph. X dash, y dash. Okay students, this is origin. Now here it is 90, pi, okay, 270, okay, 2 pi, 450, and here it is minus 90, minus pi, minus 3 pi radius by 2, minus 2 pi, minus 5 pi by 2. So on the y axis, y belongs to 0 to pi, no? So that we get the graph 0 to pi only. 0 to pi only. Okay. So you know students, okay, how do you get whose graph? When you put domain value 0 here, okay, cos 0, 1. Where do you get 1? 0 only, this point only. When you put 90 here, cos 90, students, tell me, domain value x 90 if you would like to write here. Okay, so cos 90, 0. So where do you get a cos inverse of 0? Here. So y equal to cos inverse of cos x. So you get from 0 to pi. 0 to pi. See, 0. You get the line like this. When it is pi. So cos inverse of, students, so here cos pi. Now cos inverse of cos pi value is, so minus 1. Now again cos inverse of this minus 1 you have to write as cos pi, which is equal to pi. So domain is pi, respective range is pi, pi you will get here. Okay na students. Similarly, when you write domain value 90, cos inverse of 90, cos 90 0. Again the 0 you have to express cos 90. Finally you will get 90. So domain is 90, range is 90. 90 here, somewhere here you will get 90. So see here. So 0 to pi you get the line like this, y equal to x only directly. Cos inverse of cos x equal to x. So this is y equal to x line. Same like previous one. It makes 45 degrees angle with positive x axis. Okay. And 0 to pi you got the graph like this, no? And same pi to 2 pi. 0 to pi you got strictly increases. And pi to 2 pi you will get strictly decreases. See, like this you will get. Graph must be 0 to pi only, not like a previous sine inverse of sin x. So that we have got between minus 90 to plus 90. Below the x-axis also you got that sine inverse of sin x graph, but here this y belongs to, as I said to you, 0 to pi. So that this graph must be 0 to pi. See, 0 to pi you get strictly increases. Again, when you take x value, pi to 2 pi strictly decreases. And again 2 pi to here, somewhere here you will get okay, pi, 2 pi, 3 pi you will get. So strictly increases. And this side also 0 to okay minus pi, here you will get strictly increases. Again this pi to or to minus 2 pi you will get like this, and it will go like this, and so on. Okay students, this okay result will be x. When x value 0 to pi, when you give x equal to 0 to pi, your respective range value is directly x. Directly x, whichever x you assign from 0 to pi, so direct x you can write. Okay, so next, if you assign any x value from 0 pi to 2 pi here, pi to 2 pi, and range will be this line. What is the equation of this line means? So here it makes 135 degrees angle with x-axis, positive x-axis. Hence whose slope is minus 1. And here it is passing through 2 pi comma 0. Okay. Now having slope minus 1 and passing through 2 pi comma 0. Now apply point slope form of a line equation. Now y minus y1. y1 value is here 0. M value minus 1. X minus x1 2 pi. Now y equal to, what is this? Minus x minus into minus plus. So this line equation is 2 pi minus x. Okay. Y equal to how much, Amma? 2 pi minus x. Shall I give you one problem? Now see. Take any x value from pi to 2 pi. 180 above and 360 below. Shall I take previous one? 225 degrees. Now write x equal to 225. Cos inverse of cos 225. Express in radian measure. Pi pi radians by 4. Now what is the result for this? Don't say it as 5 pi radians by 4. Because this range should belong to the 0 to pi. Okay, but 0 to pi, it is beyond the 0 to pi, 225, more than pi. So this is not right answer for this question. So that you have to use this formula, 2 pi minus x. 2 pi minus x. X value is here. X value we kept to pi, 5 pi radians by 4, no? Right here. 5 pi radians by 4. Okay. So how much is this? 360. 360 minus 225. How much, Amma? So 135 degrees. 135 means 3 pi radians by 4. Okay, na? Now 135 belongs to 0 to pi, no? Hence our answer is correct. Okay, na students? Similarly, so sometimes your angle will be given to you 3. So cos inverse of cos 3. 3 means what you have to understand about this. It is there in radian measure. So again, so 3 into 57 degrees 18 minutes. It is smaller than 180. So range can be 0 to pi, no? Hence directly cos inverse of cos 3 is 3 you can write. Because 3 radians means 3 into 57 degrees 18 minutes. So below 180 only. Directly you can write 3. But if it is given 4 radians, 4. So 4 into 57 degrees 18 minutes. So it is more than 200. Almost 240 change. Okay, na 240 change, no, smaller than, nearby 240, like 237 to 238 degrees you will get for x. Okay, but when angle belongs to around 240, So it is belonging to this interval, no? Pi to 2 pi. So in that case, your y value is 2 pi minus x. 2 pi minus x. Now write here 2 pi minus 3 you have to take. 2 pi minus 3. So cos inverse of cos 4 is, 2 pi minus 4. Cos inverse of cos 4 is how much? 2 pi minus 4 you have to write. Okay? Right. So, okay students, similarly here, in this interval y equal to x. In this interval y equal to 2 pi minus x. But here, in this interval, when x belongs to 2 pi radius to 3 pi radius, then what you have to write for y? So it is passing through 2 pi comma 0 and having slope 1. So y minus y1. y1 is 0. M value 1. X minus x1. x1 is 2 pi. Now simplify. So y equal to x minus 2 pi. Okay students. Suppose x belongs to in this interval from where to where? 2 pi to 3 pi. Means you can take this 450 degrees. So cos inverse of cos 450 degrees. 450 degrees means 5 radius by 2. 5 radius by 5 into pi radius by 2. So don't write this result as 5 into 90 degrees. This is absolutely wrong because we should get range 0 to pi. Then which formula you have to use? This formula. So this line equation is y equal to x minus 2 pi. X minus 2 pi. Okay now. So here x value is how much? Here x we are taking 550 degrees. No, 450. So 450 degrees minus 2 pi radians. So which is equal to 90 radians. 90 degrees. 90 degrees belongs to this interval, no? So pi radius by 2 means 90 degrees. That belongs to 0 to pi. Okay. I hope you have understood the graph of this cos inverse of cos x. And also you might have observed how the applications will be based on this function. Okay. Now similarly let us go to the tan function and whose inverse function. Right students, now let us observe y equal to f of x equal to tan x and also y equal to f of x equal to tan inverse of x. Now tell me students, what is the principal domain of tan x? Open interval of minus 90 to plus 90. And whereas range is set of real numbers. When you go to whose inverse function, so domain is set of real numbers, whereas range is minus 90 to 90. Okay? Right. Now let us draw both functions graphs on the same graph paper. Right. X, x dash, y, y dash. Now see on the x axis here domain minus 90 to 90. Here you can take minus 90 and here you can take plus 90. And whereas range is capital R. So you know how the graph of tan x between this. So you will get strictly increases. You get the graph of tan x between minus 90 to 90 like this. Strictly increases. Along with the y-axis it will go. If you draw the vertical lines through the minus 90 plus 90, that two vertical lines should not touch this curve. It may touch at infinitely many distance, but we cannot recognize that point of intersection. Hence, these vertical lines will be called asymptotes for this curve. What is this? X equal to 90. What is this line? X equal to minus 90. Both are asymptotes for this tan x in this interval. Asymptote, you know. Asymptote is a one line, okay, that is actually tangent to this curve, but where it touches that curve, we don't know. It may touch it infinitely many distance. So that we are saying that tangent as asymptote, because we people are can't able to recognize the point of intersection or point of touching or point of contact. Hence we are saying the tangent as asymptote. Okay. So if you draw vertical line x equal to 90 and x equal to minus 90, so it should not touch this curve. This is the graph of tan x in this interval. Now go to your domain. For tan inverse of x, domain is entire x-axis, but range must be minus 90 to 90. Where you have to take minus 90 on the x-axis, y-axis here minus 90, on the y-axis plus 90 here. Now in the tan x is strictly increases now in this interval, and tan inverse of x also strictly increases. You get the graph like this. Okay, between minus 90 to 90 you will get the curve like this. You will get. See. It will go like this, minus 90 here along the x-axis. Domain is set of real numbers. Along the x-axis you can take domain, but whereas range will be minus 90 to 90. Through the 90, through the minus 90, if you draw the horizontal line means here this one and this one. Yeah, this line equation x equal to 90. This line equation x equal to minus 90. Both are asymptotes for this tan inverse of x graph. For this tan inverse of x, these two are called asymptotes, because where do they touch? We don't know. Hence these will be asymptotes. Okay now, both graphs again mirror images for a line y equal to x in the interval minus 90 to plus 90, but open. Opens are okay here. What is this? Y equal to x line between minus 90 to 90, open interval of minus 90 to 90. Okay, y should not take this minus 90 to 90. Okay, so that here I kept open circles. So here this what is the equation of this line? Y equal to x. So for this line, so okay, this tan x and tan inverse of x both are mirror images. Okay, so this is the graph of tan x. Okay, it is image of tan inverse of x with respect to y equal to x, and this is the graph of tan inverse of x. That will be image for tan x through y equal to x line. Okay, I hope you have understood this tan x and tan inverse of x graphs, which I have drawn on the same graph paper. Okay students, so here tan x is strictly increases and whose inverse also strictly increases. Okay, right. Now let us go to combination of these two functions. So that will be periodic function. So tan inverse of tan x. Okay students, tan inverse of tan x. Alright. Now students, tell me, what do you want to say? It is equal to x, or if x belongs to minus 90 to 90, it is okay. But every time this x need not be minus 90 to 90. Okay. So students, y equal to tan inverse of tan x, where y must be belonging to open interval of minus 90 to 90. Observe this point. When you take tan inverse of x left side, which will come as tan y, which is equal to tan x. Now, what is the general solution of this equation? Y equal to n pi plus x, where n belongs to an integer. If you put n equal to 0, your respect to range y will be x. If n is equal to 1, so y will be pi plus x. If n is equal to minus 1, y will be minus pi plus x. If n equal to 2, here y will be 2 pi plus x and so on. Okay? Now observe the graph of this function. Okay students? Right. Now observe this y equal to tan inverse of tan x graph. X dash, y dash. Okay students, right. Y belongs to minus 90 to 90 on the y axis. So here you take minus 90 on y axis, here plus 90. So on the x axis, here it is 90, here you can take pi, here 2 pi, here 3 pi by 2, here minus pi by 2, here minus pi, here minus 2 pi, minus 3 pi by 2 and so on. So you know, in the interval domain minus 90 to 90, your range is also minus 90 to 90, no? So that here keep open circles and connect them. This will be the range y equal to x. When x belongs to minus 90 to 90 here, your respect to range is also minus 90 to 90. When x value is more than 90 and less than, okay, here after pi, here 3 pi by 2 will come, sorry, 3 pi by 2, here 2 pi. When x value is more than 90, less than 270, so here you will get like this. Here it is open circle, here it is open circle, because you know tan function will not be defined at odd multiples of 90. 90 1s are 93s are 95s are 90 minus 1s are 90 minus 3s are 90 minus 5s are. So that there I am keeping open circles. So if x belongs to more than 270, less than 450 degrees, you get the graph like this. Open circle, open circle. When you move here, 90, your open circle. Okay, here also 3 pi by 2, here minus 2 pi. Open circle. Okay, next. It goes like this. So it is also a periodic function. After how much length of interval, same graph is getting pi. Minus 90 to 90 length is pi now, increasing. Mala pi by 2 to 3 pi by 2, increasing like that. Okay students, now what do you comment? Tell me, what is the equation of this line? So passing through 0, 0 having slope 1, so that y equal to x you will get. It is passing through pi, 0 and having slope 1. Then what is the equation of this line is y minus y1. y1 is 0. M value 1. X minus x1. x1 is pi. So that y equal to, what is the name of this line? Y equal to x minus pi. And this one, tell me, y equal to 2 pi minus x will come. Same like this, x minus 2 pi, no? X minus 2 pi. And here also, y equal to m value 1. So x minus pi, x plus y will come. This is y equal to x plus 2 pi. You know, applications, same like previous problems. If x belongs to in this interval, so what you have to take? Y equal to x minus pi. So same, y equal to tan inverse of tan 225 degrees. 225 degrees means pi radians by 2. Is this result is pi radians by 2? No. We must get, so y value in the interval minus 90 to 90. But here 5 pi radians by 2 means 225. Result must be minus 90 to 90. So that when x belongs to 5 pi radians by 2, so what is the definition for y? X minus pi. X value is 225. 225 minus pi, 45. 45 is the result. Okay. So this is also a periodic function and whose period is pi, and you have to do the problems like this. Okay. So here also tan inverse of tan 3. Is this result is 3? 3 means what do we understand about 3? It is given in radian measure. Don't write it as 3. 3 means approximately nearly 180. Nearly 180 means you have to take this interval. Okay, now x minus pi. So there you have to write 3 minus pi. 3 radius minus pi is the result. Okay, students. Right. Similarly, okay, so let us go to whose reciprocal functions. Okay, till now what we have done? So we have learned the graphs of sin x, sin inverse of x, and sin inverse of sin x, and cos x, cos inverse of x, and cos inverse of cos x, tan x, tan inverse of x, and tan inverse of tan x. Okay, now, but one more kind of functions will come. Observe those functions. See here, y equal to sin of sin inverse of x, y equal to cos of cos inverse of x, y equal to tan of tan inverse of x. Now inverse is given inside. So sin inverse of x, whichever real value you assign here, but whose range will be? So x belongs to, here you know the domain of sin inverse of x. Domain of sin inverse of x is -1 to 1. Am I right? Students, here. Okay, so you know the x value here. This on simplification, this result will be given -90 to 90 is the range, no? So if you, okay, so if this here in this place, okay, if you assign any angle from -90 to 90, for this range will be -1 to 1 you will get. Here also same, cos inverse of x, domain is -1 to 1. So -1 to 1 means range will be, students, range of this 0 to pi. So if you assign 0 to pi here, so your range will be -1 to 1. Now tan inverse of x, range will be -90 to 90. If you write -90 to 90 here, okay, so then whose respective range is set of real numbers. Okay, students. So this graph will be -1 to 1, -1 to 1 R only. So range, okay, here these are not periodic functions because whose final result we are getting -1 to 1. So suppose if you observe this graph, finally you will get -1 to 1 on the y-axis. Here -1 you may get. So here somewhere, if you write -1, so respective here -1 on the y-axis here and here 1. So you will get the graph like this only. Here y value will take from -1 to 1 in this interval only on the y-axis. Okay, now students, so that it is not a periodic function. Similarly, cos of cos inverse of x range also -1 to 1. -1 to 1 only we will get, so that this is also not periodic function. And okay, so -90 to 90. Here, whose domain you know? Okay, students. So tan inverse of x. Actually, this tan inverse of x final result. Final result means here -90 to 90. And if you write -90 to 90, your range will be R. So you will get this kind of curve only along with the y-axis. And cos inverse of x, like this only you will get. And sin of sin inverse of x, one line only you will get. But tan of tan inverse of x, you get between -90 to 90 increase in function. So what you people are observing? So these functions are not periodic functions like previous one. Sin inverse of sin x, cos inverse of cos x, tan inverse of tan x. That three functions were periodic functions. But when the inverse is given inside of the bracket, so which are not periodic functions. These are non-periodic functions. So in this case range is minus 1 to 1. In this case range is minus 1 to 1. In this case range is capital R. Why? Because sin inverse of x range is minus 90 to 90. If it is minus 90 to 90 and if you apply sin, your range is minus 1 to 1. Again, here also no confusion. Cos inverse of x range is 0 to pi. If you assign any value here 0 to pi and if you define cos, your range is minus 1 to 1 only, you will get a graph. Means you get a straight line y equal to x line. Here also you will get a straight line y equal to x between minus 1 and 1 on the y axis. So here you get the curve. Means no chances to repeat the graph. Okay, hence these are called non-periodic functions. Okay, so whose period is not possible. But sin inverse of sin x period was 2 pi. Cos inverse of cos x period was 2 pi. Tan inverse of tan x period was pi. Okay, now let us go to whose inverse functions. Right, now see, let us observe cot x function first. Y equal to cot x and y equal to cot inverse of x. You know, whose principal domain? Open interval of 0 to pi, and whereas range is set of real numbers. And whose principal domain is, so here for the cot inverse of x, domain is set of real numbers and range is 0 to pi. Okay, now let us see whose graphs on the same graph paper. X, x dash, y, y dash. Now 0 to pi. Okay, so now tell me 0 to pi. Here it is 0 and here it is you can take pi. Now draw the graph of this cot x. Okay, principal domain is 0 to pi. So if you take any value, when you write theta 0, cot 0, students tell me, cot 0, 0 and cot pi, cot 0 is not defined, 0 to pi. How do you get a graph of this cot function? Tell me. So when you write 90, cot 90 is 0. Okay, here domain value 0 to pi amma. So here domain value, shall I take here 0 and here it is pi. Here 90 and here it is pi. Okay, right. Tell me, how do you get this graph between the 0 to pi? Okay, when you write 45 degrees, cot 45 is 1, 45 here, 1 you may get here. Okay, so here this graph you will get like this amma. Pi no, okay, so 135 minus 1. Tell me the graph of this cot function in the interval 0 to pi. So when it is here, you get like this. So pi means 180 degrees, but 180 is not including. When you write 90 here, cot 90 is 0. So when you here it is open 0 to pi range. Right, you get the graph like this. Okay, this is the graph of cot x in the interval 0 to pi. It will go like this. Through the 0, through the pi, if you draw the vertical lines, that vertical line never intersect this curve. Okay, so through the 0 means y-axis equation x equal to 0. Through the pi means x equal to pi. This x equal to 0, x equal to pi are the asymptotes for this curve. Asymptotes means tangents only, which may intersect the curve at infinitely many distances. Okay, we cannot able to recognize that point of contact. Okay, right. This is the graph of cortex in the interval 0 to pi. Range will be along with the y-axis. Now go here. 0 to pi. Okay, it is strictly decreasing now, ma. Now cot inverse also strictly decreases. How do you get whose graph? Tell me. So 0 to pi you have to get the graph. Tell me. Take any real number. Take any real number and substitute for x and go for simplification. Graph must be 0 to pi. So strictly decreases. When you write, students tell me, strictly decreases. When you put 90 degrees, 0. When it is 0, here it is 45. So it will come like this. This is the cot inverse of x graph in this interval 0 to pi. Cot inverse of x. Through the pi, through the 0. If you draw the horizontal lines, that horizontal lines should not touches this curves. Okay. What is this? Graph of cot inverse of x. What is this? Graph of cot x. Both are mirror images with respect to line. 0 to pi. Pi, here pi. So, this is y equal to x line. If you treat this as mirror, same like previous applications. So, cot x is the image of cot inverse of x and cot inverse is the image of cot x with respect to y equal to x line. Okay? Right. Both are non-periodic functions in their respective principal domains. But when you take combination of these two, like a cot inverse of cot x, see students, y equal to cot inverse of cot x. Okay students, same this one also, same like tan inverse of tan x only. You have to take left side, cot y equal to cot x. Now general solution will be y equal to n pi plus x you will get. Now draw the graph of this. Draw the graph of this. How do you get to tell me? Cot inverse of cot x. Y dash. X dash. This is origin. Okay students. Right. Now see here. Y equal to cot inverse of cot x. Okay. Here it will be defined from r minus n pi. Okay. R minus n pi, where n belongs to z, to the cot inverse of x principal domain 0 to pi. So range must be 0 to pi. Here 0, here pi. But where you have to take the break? At even multiples of 90. Like here it is open circle. And here it is, okay, here you have to take here 90. And here it is pi, here it is 3 pi by 2, 2 pi, 5 pi by 2, now here it is minus pi by 2, and here it is minus pi, minus 3 pi by 2, minus 2 pi and so on. But range must be 0 to pi. Okay, so both are not included, 0 and pi. Right, open circle, draw the graph. Here it is y equal to x. Okay. And now pi to 2 pi. Pi to 2 pi. Tell me students, how do you get? pi to 2 pi. Pi is not included, 2 pi is not included. So you get the graph like this. And 2 pi to 3 pi, open circle. Same like tan inverse of tan x, but that you got minus 90 to 90, no, it is 0 to pi. But here, these extremes are not included, hence I am keeping open circles. So here, open circle, okay. So here it is open circle. Here it is open circle. Here it is open circle. Like this you will get. So it is passing through pi comma 0. And having slope 1. Because here which makes 45 degrees. So now y minus y1. y1 is 0. M value 1. X minus x1 pi. So this is y equal to x minus pi. Okay. So this is y equal to x minus 2 pi. And what about this y equal to x plus pi? This is y equal to x plus 2 pi and so on. Okay. Applications are same like previous one. Okay. So same cot inverse of cot 225. What is the result? Do you want to say 225? No. So here this x belongs to 225 means this interval. Result is x minus pi. X minus pi means here pi radius by 2 minus pi, which is equal to 45. 45 which belongs to 0 to pi only, no? I think you have understood this cot inverse of cot x. It is also periodic function. Period is pi because after pi interval same shape of graph is repeating. So from here to here pi, graph is repeating. From here to here pi, graph is repeating. From here to here pi, length is pi, same shape of graph is repeating after length of pi interval. Hence it is a periodic function with period pi. Right. Now let us go to the cosec inverse and cosec x. Okay students, now let us observe the graph of y equal to cosec x and y equal to cosec inverse of x. Now the domain is, so cosec inverse of x domain, principal domain we want. So close interval of minus pi by 2 to pi by 2, but 0 must be subtracted. And whereas range is range for the cosec inverse of x minus infinity to minus 1 union 1 to infinity. And whereas for this cosec inverse of x minus infinity to minus 1 union 1 to infinity is the domain, and range same minus 90 to 90. So 0 must be subtracted. Okay students, now draw the graphs of those two functions on the same graph paper. Tell me, how do we draw? Same like previous functions only. Same like previous functions. See the graph of cosec x first. X dash, y dash. Okay students. Right? So what is the domain of cosec x? Principal domain minus 90 to 90. Take here minus 90 and here it is plus 90. Here it is pi, 3 pi by 2, 2 pi and so on, minus pi, minus 3 pi by 2. Okay, and the range 1 above and minus 1 below. So now draw the graph from 0 to minus 90 to pi, minus 90 to 0. So how do we get? When x is exactly 90, cosec 90 1. So in this interval, so cosec x graph like this you will get. Here it is when domain values origin to here. So y equal to cosec x graph I am drawing. When you take x value from 0 to 90, it is strictly decreases. Okay. So but this curve will not touches the y axis. Okay. So right, observe that. Because your domain value should not be 0. Cosec 0 not defined, no? So that we must not assign x equal to 0. So from 0 to 90, you get the cosec x graph like this. It is decreases only. And when you take, here you know, principal domain is minus 90 to 90. But 0 is subtracted, no? So that first I took 0 to 90. I got the graph like this. Next I am going to left side of 0. Minus 90 to 0. Okay? So minus 90 to 0, you will get the graph like this. When you put x is exactly minus 90, minus 1 is the range. So you get like this. It goes like this. But it never touches the y-axis. This is y-axis. So this is the graph of cosec x. This is the graph of cosec x in the interval minus 90 to 90. This is also graph of cosec x in the interval 0 to pi. Decreasing function only. Domain values are increases, but the graph is decreasing. Okay. Now let us go to whose inverse. Cosec inverse of x. Domain is minus infinity to minus 1, union 1 to infinity. And whereas range, so minus 90 to 90, 0 must be subtracted. Okay, right. Students, tell me. Minus infinity to minus 1. Minus infinity to, see, minus 1. Range will be minus pi to 0. Okay. When you put exactly minus 1, respect to range is this, no? When you write x equal to here, minus 1, respect to range is minus 1. Okay. Now, range should be minus 90 to 0. Now, domain values you have to take along with x-axis here. Range is, so minus pi to 0, students. See, you get the graph like this. See, range, here it is minus pi, no, minus 1, no? Here it is minus 1, here you may get minus pi by 2. When you put x is exactly minus 90, here your respect to, your x is exactly minus 90, respect to range is minus pi by 2. Minus pi by 2 means, so here it is domain value minus 1. Here it is 1. Minus 1, range is 1. Here you will get. Graph will come like this. It will go like this. This is the cosec inverse of x graph. What is this? Graph of cosec inverse of x. So from minus infinity to minus 1 along with the x-axis. Here it is minus infinity. I am moving from minus infinity to 1. I reached 1. Respect to range is minus 90. Similarly, 1 to infinity. Where is 1 on the x-axis? Here. Here it is 1. 1 to infinity means I am going like this. Okay. Now when it is exactly 1. Okay. So if it is exactly 1, here respect to range is 90. So here 1, no, where is 90? Here if it is 1, 90 will be here. Now 1, no, 90, you may get here. Okay. So your graph will go like this. Along with the x-axis, but it never touches the x-axis. Okay. This is the graph of cosec inverse of x in this domain. Range will be minus 90 to 90, but at 0 you are getting the break. 0 means that is x-axis. X-axis equation y equal to 0. Y equal to 0 is the asymptote for cosec inverse of x. This cosec inverse of x graph is coming along with the x-axis, but that curve is not touching the x-axis. Hence, x-axis is the asymptote for this cosec inverse of x. Okay, students. So, both are mirror images with respect to y equal to x. Y equal to x from minus 90 to plus 90. Okay. So, take minus 90 here to plus 90, and here plus 90 to here 90. Okay. So, this is y equal to x line. So, both functions are mirror images with respect to y equal to x line. And now let us go to cosec inverse of cosec x. You will get periodic function now. Right, whose graph same like sin inverse of sin x only. Cosec inverse of cosec x. Okay, here what is the domain for x? So here this will define from r minus n pi, where n belongs to z, but whereas the range must be minus 90 to plus 90, 0 must be subtracted. Okay, students. Right. So now let us draw whose graph. X, x dash, y, y dash. So this is origin. Now here take 90, here pi, 3 pi by 2, 2 pi, right here 5 pi by 2, 3 pi. Now here it is minus 90, minus pi, minus 3 pi by 2, minus 2 pi. And on the y-axis you can take here 1, here 90. Here it is minus 1, here it is minus 90. Okay, students. Now draw whose graph. How do we get? Tell me. At 0 we are getting break now. So here open circle. Now extremes are closed. Closed. Again, students, in this interval, same like sin x graph only you will get. So sin x graph was okay, you got like this now. So but here at 0, at n pi we are domain values we are subtracting. So here you get like this. Here it is closed, open circle. Now here at pi you have to write open circle. Okay, range will be minus 90 to 90. 0 must be subtracted. So here open. Where 2 pi to 0 to pi. Okay. Where minus 90 to 90, minus 90 to 270, 270 to 570. Here it is open circle. Sir, here it is darked only. It is included. But here write open circle. Okay. Right. Now here minus pi. Tell me, students, here you have to open it. Now here it is closed. Here it is open. So this is the graph of cosec inverse of cosec x, where 0, so breaks we are getting. Okay, students. So see here, this is the domain for this function, and whereas range is this. No confusion, same like previous. Okay, previous applications. What is the name of this curve? Y equal to x, but x equal to 0 should not be included. Right, here also it is making a minor here, passing through pi comma 0 and having slope minus 1. Now what is the equation of this line? Y minus y1. y1 means 0. M value minus 1. X minus x1. x1 means pi. Now simplify. Y equal to, students, pi minus x you will get. What is the name of this line? Y equal to pi minus x. Now what is the name of this line? Slope will be 1, making 45 degrees angle. Y minus y1, 0. Passing through 2 pi comma 0. So 1 into x minus 2 pi. So what is the name of this line? Y equal to x minus 2 pi. Okay students, similarly can you able to find this line equations? Passing through minus pi comma 0, passing through minus 2 pi comma 0. Do that work by yourself. Okay, you know how the applications will be based on, same like sine inverse of sine x. Okay, now let us go to last function, that is secant inverse of secant x. But before going to learn that, so let us see the secant x and secant inverse of x graph. Now right, see this, y equal to secant x function and y equal to secant inverse of x. Now tell me what is its domain? R minus. So secant function will not be defined at odd multiples of 90. 2n plus 1 into 90. This you have to subtract, but here you have to take principal domain. So principal domain for the secant function is closed interval of 0 to pi, but 90 must be subtracted. Okay. So right, now let us go to whose range. Range will be same, minus infinity to minus 1, closed union 1 to infinity. Now go to the secant inverse of x. Reverse. Domain is minus infinity to minus 1, closed union 1 to infinity. Whereas the range will be closed interval of 0 to pi. But okay, you get the breaks at 90 degrees. Okay, now shall we see both graphs on the same graph paper? Now let us go to graph part. Right, see this. X dash, y dash. Okay students, right. Now see here, it is 90, here it is pi, here it is 3 pi by 2, here it is 2 pi, here 5 pi by 2, here it is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So here you can take 1, here it is 90, here it is pi, and here it is minus 1, here minus 90, here it is minus pi, and so on. Okay students, what is the principal domain of secant x? 0 to pi. But where we are getting breaks? Okay, 90 no? Tell me students, how do you get whose graph? So 0 to 90. Secant 90 is not defined now. So what do you get? When you write 0, respect to range is 1. Okay. So 0 to 1, 0 to 90 it strictly increases. Like this you will get. Through the 90, if you draw the vertical line, it should not touch. This will be the secant inverse of x graph in the interval 0 to pi by 2. And pi by 2 to pi, when you put x as pi, secant inverse of pi amma, respect to range is minus 1. So you get the graph like this. It will go. But through the 90, if you draw the vertical line, that is x equal to 90, because passing through pi by 2 now, vertical line passing through pi by 2 is x equal to 90. That x equal to 90 is the asymptote for this secant x graph in its principal domain 0 to 90, where 90 you are getting the break. Here from 0 to 90 strictly increases, from 90 to pi strictly increases, because domain values are increases, range is increasing. Domain values increasing, range is increasing. So this is the graph of secant x in the interval 0 to pi. Now let us go to whose inverse. This is the graph of secant x amma. Now let us go to whose inverse function, minus infinity to minus 1, union 1 to infinity is the domain. Okay, so when you put minus 1, where it is minus 1 on the x-axis? Here. When you write minus 1, okay, your range will be pi, you will get. Where it is pi? Here. Minus pi. No. Okay. Pi you will get. When it is minus 1, respect to range is pi. Here you will get. Here it is minus 1, on the x-axis. Here it is plus 1. When you put minus 1, okay, students, secant inverse of minus 1. This one you have to express in terms of secant pi. So result will be pi. So minus 1 is domain value, respect to range is pi. Minus 1 comma pi. Okay, students. Now, okay, tell me next. When you write, okay, how do you get in this? 0 to pi. And when you write 1, secant inverse of 1. When do you get secant inverse of 1? Domain value 1 means secant 0. So you get this one only. Okay, 0 comma 1. On the x-axis 0, y-axis 1. Okay, next. Minus infinity to minus 1, union 1 to infinity. This is the domain. And range must be closed interval of 0 to pi. But 90 must be subtracted. 90 we have to subtract. Tell me, how do we get? Minus 1 I kept. So you got pi. Okay. Next, when you write plus 1, students tell me, 0 to pi, no? 0 to pi by 2. 0 domain, see, minus infinity to minus 1. When you write minus 1, you are getting respect to range y. This is minus 1 comma pi point. Okay. Now when you write plus 1, number, plus 1 means 0. 0 it is 1. Okay. Right. Now you get the graph like this. Students, you get the graph like this. From where to where? So here. Your domain value is minus infinity to minus 1. You are getting like this. You are reaching 1 minus 1 comma pi. Next 1 to students. When you assign, okay, when do you get result is, see, okay, 1 above. Next minus infinity to minus 1 we have given. Now we are giving 1 to infinity. So 1 to infinity. When you write 1, where do you get 1? At 0 degrees, no? See here, secant inverse of 1. When do you get 1, number? Secant 0. So where it is 1 comma 0? This point only, 1 comma 0. Secant inverse of 1. When you write 1 here, it is going to be secant 0. Respect to range 0. Domain is 1, range is 0 means this point. See, you get like this. If you draw a horizontal line through the 1, this should not. So, students, range will be, see, minus 90 to 90, but what should not be included? Sorry, 0 to pi. 0 to pi. 90 must be subtracted, no? Through the 90, not here, amma. See, students, here graph will come like this. At 90 you have to get the break, and here also, students. So you get graph like this. Through the pi by 2, if you draw the vertical horizontal line, that line should not touches this curve, inverse function curve. So what is this? Graph of secant inverse of x. This is also graph of secant inverse of x. Now you know the domain of secant inverse of x, minus infinity to minus 1. Here it is strictly increases. Now we have reached the pi. Now I am giving domain value 1 above. 1 above means here it is going like that. Okay, but it should not touch this pi. by 2 means here what is this? Y equal to pi by 2 line. This is the curve of secant inverse of x. It should not touch this y equal to pi by 2 because in its range it is doesn't contain no, hence this y equal to pi by 2 is the asymptote for the secant inverse of x. Okay, see what is this secant x graph in the interval 0 to pi, 90 is subtracted, and what is this graph of secant inverse of x. So in the interval minus infinity to minus 1 and 1 to infinity, range is 0 to pi, but 90 is subtracted. I hope you have understood this, and both are mirror images with respect to the line y equal to x. Here pi, here it is pi, no, this is y equal to x line amma, between 0 to pi. Okay, so here at 90 you have to give the break. Okay, with respect to this line, so this secant x and secant inverse x are mirror images, means the graph of secant inverse of x is the image of secant x, and the graph of secant x is the image of secant inverse of x with respect to y equal to x, where 90 should not be included for y. Observe that. I hope you have understood this. Now let us go to the secant of secant inverse of x graph. Secant of secant inverse of x graph. Same like cos of cos inverse of x graph only, students. Secant inverse of secant x. Now observe whose graph. X dash, y dash. Students, so 0 here it is pi, here it is 90, here it is pi, here it is 3 pi by 2, and here it is 2 pi, here it is minus 90, here it is minus pi, here it is minus 3 pi by 2, and so on. Okay, now 0 to pi you get here at 90 degrees you get the break. So you get the graph like this. Both are included. Okay. Now pi to 2 pi. So here at odd multiple of 90 you will get a break. Similarly, so here also at 90, here you may get 90 here. So where you have to take break. Okay, 0 to minus pi and minus 2 pi to pi. Here you have to take break. Okay, so you know this is y equal to x line, and this will be passing through 2 pi comma 0, having slope negative, so that y equal to minus 1 x minus 2 pi. So when you send minus inside, 2 pi minus x. Okay, so what about this passing through 0 comma y equal to minus x line. So this is minus 2 pi now. So that here y equal to, so slope is positive because here making 45 degrees. So what do you get? X plus 2 pi. This is y equal to minus x. This is y equal to x. This is 2 pi minus x. Okay, students, and so on. So this is the graph of secant inverse of secant x. Okay, it is a periodic function after 2 pi length of interval, increasing, decreasing, again increasing, decreasing. Same shape of graph is getting, hence whose period is 2 pi. Okay, now students, same like that. If inside is inverse is given, so here similarly cosec inverse of cosec inverse of x. Okay, so these functions are not periodic functions. Okay, so observe that. But here when inverse is given outside, those are periodic functions. Okay, students, I hope you have understood this class. Okay, so in this class I tried to explain all those basic trigonometric functions graphs in its principal domain and whose inverses and whose combination of principal ratios and whose inverses like sine inverse of sin x and cos inverse of cos x and tan inverse of tan x and cosec inverse of cosec x, secant inverse of secant x, cot inverse of cot x. And also I explained you basic applications based on this combination of sine functions and whose inverse functions, which are very important in IIT mains and advanced point of view. And this inverse trigonometric functions chapter is very important in competitive exams, okay, like any other engineering entrance exams and also IIT mains and advanced. Thank you students. I hope you can utilize this my class. Thank you one and all.